Okay, reviewing for this test, it's officially called a communication assessment. So, but we all know it's about exponentials, and it's communications number 6. And this is a typical set of 3 kind of normal questions that you're expected to know how to do by now. This doubling every 7 days thing is something we haven't spent a ton of time on. But if you start with 20 and it doubles every 7 days, it goes like this. The start with 20 part should have been obvious. Then the doubling obviously is a growth factor, and some people will screw this up, but 1 plus 1. You do not put 1 plus 2 in there. I could see somebody thinking that. Doubling is 1 plus 1. Why? Because the first time you multiply it by 1, it just brings back the original. That's the thing that doubles it. Do you get that 20 times 1 plus 1 would be 40, and it is doubling? Okay, but if I double it every 7 days, I have to put x over 7, and then this is really critical. If you don't have this part, you're going to lose at least 5% in days. Because this formula could mean 7 years it's going to double, or 700 years, or 7 millennia, or whatever. So anyway, you got to clarify what it's in. Raise your hand if you're comfortable with that kind. Okay, good. Next kind is this one. If I give you 2 points, we have practiced these, but they're a little bit tricky. So I'm going to first of all just say starting value is 3, and yes, it's okay. In this kind of problem, it turns out we didn't do the kind of problem that you have to stick in this point to get the starting value. These you can just say, if it starts at 3, you put a 3 right there. Done. Now the next step is you put this point in, and where can I put it? It's an x and a y, so you put it 9 for the x and 12 for the y. And then you solve. So I'm going to divide by 3 on both sides, and I get 4 equals b to the 9th. I was dividing 3, dividing 3. Okay? Now I can get the b alone by putting both to the power of 1/9. Therefore, b is 4 to the 1/9. I now know a and b. So y equals a, which was 3. And then b is times 4. I'd put it in parentheses, to the 1/9. And then you just need one more thing, an x. And to make it safest, I just put it x on top and say x over 9. Any questions about that one? How many of you feel confident on that kind? Okay, good. Then let's move on to this kind. Here's the mistake a lot of people make on this one. They see 2/3, they think right away, okay, that's got to be decay because it's a number smaller than 1. What are they forgetting? The exponent is negative, and that makes it flip, so it's y equals 3/2 to the x. All I did is make that negative get factored in. So that's like y equals, I'm going to make it 1 plus 1/2 because I like to write it that way, and then I know it's 50% growth. Hopefully you can see a graph that looks fairly steep like that. That's your sketch. How do you write the limits on both ends then? The lim of the function as x approaches negative infinity, means you go way this way, the limit would be 0. And then the limit of the function as x approaches positive infinity, that means way this way. And this is the x, this is the y. The answer to these are always a y, they're a height. And the height when I get there is unlimited. It's infinity, I would say. Okay, so as you approach negative infinity, it's 0. As you approach infinity, it's infinity. All right, I started you off with 3 fairly easy questions. Those shouldn't have been too bad. We have done limits before. All right, next topic. Let's talk about what order you'd have to do things in. This has been on almost every test, and I'm still amazed at how many people have trouble with this. So here's a normal one. Actually, I'll use numbers. Let's say there's a 2 here, and then there's a 3 to the power of x minus 5, and then plus 7. If the parent here is y equals 3 to the x, if you boil it all down, that would be the simplest one. That's the parent function. So that means if I were you, would like circle that. Then the other 3 things are transformations, stuff you're doing to the function. The order you do them in is important, and I have suggested you always start on the inside. In this, it's particularly challenging to know what the inside is. This is not the inside. The inside is by the x. in all of our other functions, whenever we were doing them, it's always inside by the x where the horizontal stuff happens. I shouldn't have an x in the power on this one. So like back in the old days when you're just doing quadratics like this, we put like a -4 here. It's always inside by the x. So this is the inside. And I also want to remind you that it's high-vo. Horizontal changes on the inside, vertical changes on the outside. Would you please write for me number 1, number 2, number 3, and if you start on the inside, there is only one right way to do this. This is first, this is second, this is third. You can't use the word flip. That's not mathy enough. We have to be more careful than that. You can use the words up and down. Those are okay. Best words you should almost always include would be vertical and horizontal. Right and left are also legal words. You don't have to try to make up some complicated way of saying move to the right. You can just say right. Okay, so if you're going to start on the inside, it is right 5. Okay, then you move to the outside. Things that are on the outside go in the normal order. So this is a particularly easy one because the inside is where the order gets reversed. The outside, they always stay in the same order as normal. Normally, multiplies come before adds, so this comes before that. So we're on the outside and it is normal, so therefore it's going to be the 2, which is a vertical stretch factor 2. And then the last thing is up 7. Okay, now I'm going to give you a more complicated one. Try this one. Now, considering that y equals 1/2 to the x is kind of like a classic decay pattern, that's the parent function. This one's obviously different. In which ways has it been stretched and reflected and all that kind of stuff? I'll pause for a second while you give that a shot. Okay, here we go. Numero uno. If I were you, I would have started on the inside, and that's here. Of those two, I'd be thinking, okay, one is a stretch, or a shrink, and the other one is a move. Which one should be first? Well, normally, this comes before that, but this is on the inside where things aren't normal. So we start with the -2, and we move right 2. What I've found is usually that's right there, that's where the mistake is made first. That's the first mistake people make. It is supposed to be right 2, and a lot of people think you should start with the 3. They're wrong. You've got to do opposite of normal order. This is normally first, so it isn't first if you're on the inside. It's second. So now I get to that part, and here's the next mistake people usually make. On this one, they're thinking to themselves, okay, it's 3 on the inside. So inside, at least they remember it's horizontal. Most people remember that. But then they say, they see the 3 and they think it's a horizontal stretch. It's really a horizontal shrink. Factor, and here's the next place people make a mistake. They think it's factor 3. It's not. If it's shrinking, it can't be a whole number like 3. It's 1/3. On to number 3. Now we're on the outside. We've finished the inside, and if you get this far, pretty much everybody gets it right from there, because that's where all the mistakes were made. From here we have 7 times taller. Another way to say that is a vertical stretch factor 7. And then up 4. I know that now that I've explained it, you'd be fine, but how many of you, be honest, how many of you had it right this time? And that's 3/4. All right, good. Okay, so the last, this is the last, but one of the last topics I want to talk to you about is real-world problems where we would normally go to a graph to solve it, but there's no calculators on the test. So how are we going to handle that? We're going to ask you to just leave the equation you would have graphed, and that's going to be your answer. you won't have to actually do the graphing of the equation. Now the R4 question, calcs are allowed on, which is a little bit of a pain, but that's the R4, and usually only like 1 out of every 35 people get that one right. Not even 1 per class, so I'm not too concerned about the R4. All right. So when it comes to your real-world problems, there's mainly, this is about growth and decay, right? So let's say that you have a car that's worth $25,000 to start with. Do you get that unless you get incredibly lucky to have bought a car that becomes a classic, that the cars go down in value? And they aren't worth as much next year and the year after that, and eventually they get all rusty and nasty, and even if you've kept them in really good condition, they still go down in value. They just don't go down as fast. So let's say it starts at $25,000, and then by the end, when you're selling it, it's like $5,000. And I know this from real experience, except I haven't bought them on the top end, but I've bought them on the bottom end when somebody's like ready to get rid of their car. The trick is you don't want to buy somebody's car who's just about, like the car is pretty much all used up, like there's nothing left. You got to catch it when the value has gone down, but it's going to die right there, and you never know for sure, but you can judge to some extent based on how many miles it has on it. But if it's getting, a lot of cars nowadays will make it to 200,000 miles. Not all cars, but a lot. And you got to be careful which ones. But a lot of people at about 100,000 miles or even 150,000 miles, they'll get rid of it right about here. And that's where I try to ride, because look at how much it doesn't go down. You buy it for $5,000 and you can sell it a few years later for $5,000. You're not losing the money. Whereas if you start here at a $25,000 car and you sell it here after 4 or 5 years, look at how much it's gone down. You know what I mean? So anyway, everybody gets to make their own choices on that. And if you have more money, obviously it's easier for you to say, I don't mind spending that $10,000 I'm going to lose on that. It's okay with me because I'm going to have a nice car during that time. And depending on how much you have, can make those decisions. Some people would make the argument, even if I could afford it, I'd rather try to not lose much money on my cars no matter what. A lot of people do a compromise and they ride it like from here, because look at how much drop there is in that very first year. They try to ride it from here to here. So you're losing some value, but not nearly as bad as at the very beginning. So you'll all get to decide this when you're older. But what you'll have to deal with tomorrow would be a question like this. This is obviously decayed in value. Let's say that it did it over the course of 9 years, from here to here. Write me the equation that would represent that situation. All comes down to this. Y equals AB to the X, because that's the formula you're going to have at the end. Really, if you just knew what A and B were, you'd have it. And don't we know what A is? Yeah. What is A? 25,000. So the beginning of this is incredibly simple. So all we need to figure out is what? B. And then we'll have it. So how do we do that? That 5,000 there and that 9 years have to be used somehow, right? So where should the 9 years go? In the X, because that's time. And then where should the 5,000 go? In the Y. It's kind of like a point, 9 comma 5,000. Another way to think of it is, that's where time goes, that's where the end value goes. So you should have said 5,000, not 50,000, 5,000 equals 25,000 b to the ninth. Then I'm going to divide by 25,000 on both sides. The 3 zeros will cancel, so it's really 5 over 25. So that's really 1 over 5. So 1/5 equals, and it was divided by 25,000 also, and all of it cancels. Then it's b to the ninth, and then the final answer is put it to the 1/9. I seem to be obsessed with 1/9 today. B is equal to 1/5 to the 1/9. Now we know A. We also know B. So we just have to put it all together. Y equals 25,000. And then it's B is 1/5 to the 1/9. And then I would cry a little bit and mark it wrong. Why? Yes? X on top over 9. Otherwise, it's not an exponential unless you have the X in there. Okay. Now, if I gave you this, and is a really complicated B, really simple question, is it growth or decay? It's decay, because that number is less than 1. All right? How about now? It's growth. What's the growth factor? What percentage growth is it? Icky. So then, you'd say this, in the first place, was 9327 over tenths, hundreds, thousands, 10,000, 100,000s. That's what it was in the first place. Do you get why I'm doing that? Why did I make it a fraction? Because what did the negative do? Flips it. That's what the negative would do, is flip it. So then I'm flipping it, and I have a starting value I don't know, and now I've got 100,000 over the top of 9327 to the X there. Now, does that help you to see that it's growth? But what's the growth factor? Well, we got to figure out how much more than 1 is it. Get what I mean? Remember me saying that you got to write everything as 1 plus or minus something? Wouldn't this be 1 plus something? So then you'd have to figure out, well, how much is 1 in terms of 9,327ths? So it's obviously 9,327 over 9,327. That's what 1 is. And it's plus some more, right? Here I'm going with this. I just have to figure out how much more I need. It's obviously some number out of 9,327. That's the growth part right there. Because the 1 isn't the growth part. That's just the beginning. And then I can tell it's growth because I'm adding. And then that fraction right there would be my growth factor. All right. I'll leave a little bit to the mystery. So I now wish to hand out to you your review packet. We may do some together, so I'll just pause the video for a second. Okay, we got them out. Let's talk about number 1. I hope that's pretty easy, except I can see where somebody might say, what the heck is E again? It says e to the x. That's just exactly the same as if they said this, 2.718 to the x. Okay, so that's basically about 3 to the x. Is that exponential? Of course it is. It's got an x in the exponent. Then you got to answer a few questions about it. For each of the following functions, do these things. Make a basic... Oh, wait. I'm reading in the question above that. It says, in this unit, you have primarily studied 2 functions, the exponential function and the basic logistic function. We took out the basic logistic function. That's why this unit was so short. We started on a Monday, and now we're testing on Friday. Okay, so basic logistic function is not there. So if you're like looking at that later and you're like, wait a minute, what's this basic logistic thing? You aren't learning it. I'm going to just tell you briefly, just so you don't feel like you got totally left out. The basic logistic function starts going up like this, like a exponential function does, but then it does something kind of cool. It levels off. It's actually a much better thing for populations. In the real world, has the population of deer just kept going up exponentially forever. No, it levels off because of certain environmental factors, like things like to eat deer, and if there's a lot of them running around, they'll eat them. Or if there's too many deer running around, then they will end up dying because there's not enough food for all of them, especially in the wintertime. So they tend to level off like that. The basic logistic function does exactly that. It also has an asymptote down here like we have on our exponentials. But it also has an asymptote up here. And that's what a basic logistic function is. But we're not going to have tests on that. We are moving on to the next topic because basic logistics did not come up in calculus, and so we thought, okay, if we're going to pair off something at the end of the year here, let's throw that one out. All right, so if you're asked to sketch this, this is a good enough sketch. I don't need this to be perfect. And given that there's no number in front, that means there's a starting value of 1, right? If there's no other number there, then there must be a 1 there. So that means the start value right here is at 0, 1. Why? Because if you put in x is 0, do you get anything to the 0 power would come out to be 1? Makes sense, really. Okay. So then, there's your little sketch. And then from that, they're asking you for, you have the domain and range, and write an equation for any asymptotes. All right. Domain, forever both ways. Easy. Range. Lowest it goes is what? 0, but it has ever actually touched 0? Okay. All the way to the highest it goes is infinity, no limit. Okay. And then, for the part about equation for any asymptotes, the asymptote on this always runs at 0. Could that be moved? No. Even if you stretch this thing and you make it 3 times taller, it's going to get closer and closer to 0. Now, I should clarify, you can move the whole thing up, but not by multiplying. Adding. If I took this equation and said plus 5, then the whole function, including the asymptote, would move up 5. All right? So the asymptote's going to always start at 0, and the only way it would ever move is if we did that to it. Then its asymptote wouldn't be at 0 anymore, it'd be at 5, because the whole function moved up 5. All right, so how do I say the asymptote's at 0? You say, well, if it's a thing that's right on the x-axis, do you know what that means it is? What's the equation for the x-axis? It's not x equals 0. It's y equals 0. That's the asymptote. And that's going to be the asymptote 9 times out of 10. The only time it wouldn't be is if they move the function up by like adding 5 at the end, and then you'd have an asymptote of y equals 5. All right. Next part is about describing it using limits. The first thing you want to do on those is sketch them. And again, you don't have to have complicated sketches. If you're showing decay, that's a good enough sketch to write a limit. I don't care exactly how steep this is because it's getting closer and closer to 0 either way. Okay? Now, if the whole function got shifted up, that's the one time when all of a sudden your asymptote's going to change. So if you had a function like this that's decay, but it was being shifted up, now all of a sudden its asymptote isn't at 0 anymore. Its asymptote might be however far you shifted it up. Like, let's say you shifted it up 5, then your asymptote's at 5. Does that affect your limit? Yeah. Because on this end, the limit is how high will it be when I go forever that way. And if this is up 5, then your limit would be 5 on the right end. That's assuming you've shifted your function up 5. Neither 3 nor 4 were shifted. Okay, flip it to the next page. There's 2,400 moose in Minnesota at the beginning of 2012. The population declined by 35% and will continue to do so each year. Just got to write an equation for that. That should be easy peasy. MHS starting attendance for this year was around 3,000. It's actually pretty close to that. Let's say it goes up 2% every year. Well, you can write an equation for that. There's some problems about doing it in the right order, which we already went over. Some real world problems in the backside. There's a lot of real-world problems here. Yeah, but some of them are like really, they're there for a reason. So I hesitate to have you skip too many of the real-world problems. So I'm gonna say I think you should do all of them. It's the night before a test. You're not gonna have anything assigned tomorrow unless it's some silly little easy review assignment or something. There's nothing new assigned tomorrow, so you put in a longer night tonight. And besides, I gave it to you yesterday, so you had some more time to work on it. So. All right. There's your assignment. Should be a nice, easy test in coming back from having done trig and coming off of those really, really hard problems. So this is a chance for some of you to boost your grade back up again if it's dropped lower than you like it to be. So it's not going to stay this easy. It's going to get harder, but at least you can see trig is the toughest part of Precalc, and you've made it through. Yeah, it's going to come back on the final, though, so I'm going to want to review that one last time before we get to the final. Okay, that's all I got for you for today.